Hi, I'm Elise and I come from the University of Liège. I work on Mercury in Seabass. Why Mercury? Because it is very bad. It can cause mental and physical disorders, especially in the fetus. And despite the many measures taken in Europe to decrease the mercury input into the environment, concentration that we find still in many marine predators are still too high. So the question is, why is it? Do we still reject too much mercury in the environment, or does the mercury come from somewhere else? Because the nasty thing about mercury is that it is extremely volatile and it can travel for more than a year in the atmosphere and so be deposited extremely far from its point source. So, the mercury we find here in organisms, is it local or does it rather come from a more global atmospheric pollution? And to investigate that, we decided to use mercury stable isotopes. Mercury stable isotopes are reported as a small delta value for isotope 202. This is like what's being done for carbon and nitrogen isotope in trophic ecology. But mercury also displays some anomaly for some isotopes like isotope 199. And this anomaly is reported as a big delta. Now, the important thing is that these two values, they depend on different processes. So they give us different information on the mercury cycle. And by combining them, we can probably trace mercury contamination sources. The research is still in the beginning, so it's very promising, but it's a start. So what we wanted to do is to try to use these isotopes to try and answer the question, do we have global or local mercury? So what we did was we decided to sample a marine predator, the common sea bass, in 7 different sites across Europe. Of course, we measured mercury concentration, but also mercury isotopic composition. That's the point. And we first wanted to see is the isotopic composition in the different places different? Another way to put it is, can we discriminate the sampling sites just based on mercury isotopes? Answer is, yes, we can. Here you see small delta mercury 202 reported and big delta mercury 199. But we also calculated the core isotopic niche of each sampling site. And you readily see that they're different. So yes, based on mercury isotopes, we can distinguish our sampling sites. Of course, we went further in the interpretation. And if we remove the Black Sea samples because they're very strange, first thing we noticed was that the range on the x-axis is extremely narrow, especially compared to other studies who've done similar things. And we think that this might be an indication that there is a global contamination affecting all sites. Then, the other thing we noticed was that this sampling site here, from Portugal coast, had a significantly distinct signature than all other sites. And this is also our most contaminated site. And it happens to be located near a former chloralkali mine that used to reject loads of mercury in the lagoon. Sorry. And so here we have an indication that a local contamination source can impact the mercury signature, isotopic signature. And this is all I want to say today because I don't have time. And so what you have to remember is that mercury isotopes do discriminate sampling sites and do help us investigate mercury sources. And I want to thank my colleagues from Liège and Po. And thank you all for listening. And if you want to know more, the related publication is coming very soon.